my screen?
Yep.
Yeah, we can see, we can hear you,
Yeah.
all good. Yeah, thank you so
Okay.
much for taking the first place, man. It's a courage, so we appreciate it. And thanks everyone for coming. It's our first round of the project presentations, led by Jazz Visa here. So yeah, feel free, take it away, man.
Okay. So let's get started. Hi everyone. This is James Visa, and this is my project proposal for this EPF. I want to do this project to enhance this RBC capabilities in gas, and is typically basically for the advanced choosing and the transition querying. Okay, so this is my agenda. The first one is modification, and the second one is challenges, and the third and fourth one is project overview and the roadmap. So let's get started with modification. And for modification, let's say something about why current only debug trace transition or debug trace block RPCs are available in gas to features inner executions of a transition. I think some people are also familiar with Ethereum. We use this debug trace transition to feature some internal transitions for one transition. Especially this is useful for the DeFi security audits or as analysis, data analysis. They want to feature more details about a transition. But this RPC has some limits. The first is this RPC will rely on an archive node, but currently an archive node for the gas mainnet is 18 TB. This is a lot of disk usage. I think not every user or every consumer can handle those large size of the disk. And the second one is this RPC will replace some formal transitions to reconstruct the state DB and then replace the transition for this state DB. This will require actual CPU and memory resources. So for this limitations, since debug trace transition for gas is not very reliable and might use more resources, but gas is mainly adapted by other trains such as optimistic or based on something layer 2 chains or such as BNB smart chain and other chains. So if we can adapt if we can set up the chains for gas in a low cost, and so the Ethereum or other layer 2 chains can also benefit from this PR. And for the second one about currently the wallet or the app providers need to record each transition which we initiated by their I just said. Either by locally store in their local storage such as Chrome storage, or save it into a cloud server in order in order to enable users to view their transition history or trigger the transition studios, such as they need to know if this transition is accepted or not, and also need to check their nonce. But I think this is a more common requirement, and then each wallet provider do not need to individually implement them. And so if we can implement a more natural API to provide such features, it will be more standardized, and the wallet or the app providers can implement them more convenient and more useful. So here's my modification for how For the trace fleet or trace block RPC, we can generate the trace results along with the the new block mined and save the results into the local DB. Maybe we can use the GoESM FreeDB directly or something else. Then the clients can directly consume the results from the underlying DB and no need to reply anymore. So this is more fast and more resource intensive. And for the ETH get transition by send and announce RPC, we can build an index for each transition. I think this is similar to the transition lookup. And since API also need to consider about pending transition for the pending transition as they are not cognitive, we may need to consider more about them. Yeah, and this is the challenges. I think for the first one, trace fleet and trace block, is if a change log is occurred, we need to update or delete all the newly blocks and then save the new blocks in the DB. So we need more concerns about the change log. And the second one is performance impingement. If the transition execution is too large, such as this transition is very large, it's about 10 gigabytes more. So if something like this transition occurred, we need to take more about it. For the ETL get transition by send and not RPC, we need to consider more about the data consistency between the indexes and the large DB. Because we have two DB stores there separately. Okay, so below is my project of fill. This is first one is I need to add the trace namespace for in GoESM, and the second and the third one is mainly implement source RPC. And the first one, I think I also need to add ETL get transition by set and another RPC to the execution APIs, so the other clients can also implement them and set this RPC as a standard RPC. But for the trace RPC, maybe different clients such as Bishop or Navman, they might be different implemented. So this RPC may be maybe have two more discussion with the client. Okay, so below is my roadmap. So first month, I need to complete the research for this project, including the design doc and to specify the format of the request as a response. Also, the request parameter validation and the DB data structure and other things. And the second and third month, I think is the time for coding. Where I need to implement source RPCs independent. And month 4 and month 5 is benchmark and bug faces. After month 5, I can finally release the final fishing and also add the document and test case for those RPCs. Okay, thank you. This is my proposal. Is there any questions? Maybe you can write. Thank you.
Awesome. Thank you very much. Yeah, it was great. Anyone has any questions, comments? Anybody? Yeah. Okay. Yeah, I think it was great. Thank you so much, Visa. Yeah, great presentation and overview. Yeah. I think we can move on. If there are no questions, comments, feel free to ask.
Thank you.
Yeah. Thank you so much again. Awesome. Okay. Yeah, we will. So next one, Maxim, are you here? Are you ready?
Yes, I'm here.
Yeah. Awesome.
So I think that someone else is going to share his screen. Kaira, if you Are you here? Yeah, sure.
Yeah, hey,
Okay.
can
Yeah, we
you
can see.
see my screen?
Yeah, yeah.
All right.
Awesome. Yeah, go ahead.
Okay. Yeah, let's start. Yeah, so our project is a custom libp2p library for Prism. Uh, yeah, it's mentored by Manuel P. And like we are like four fellows working on this project: Richa, Max, Dev, me, and Rose. Yeah, so our primary motivation is building an in-house custom implementation and potentially replace most of the components that currently dependent on libp2p, and like we are doing this for Prism client right now. Um, yeah, also like currently most of the clients use libp2p. There are like multiple variants of libp2p, uh, like in all kinds of languages like Go, JavaScript, Java, and even NIM, and all, and like are kind of dependent on that. So yeah, this project would enable the Prism team to have uh, an independent uh, an independent libp2p library, uh, that can act as a like integral component and like not depend on some third party to maintain that. This will also eliminate a lot of redundant components, since libp2p is like a generalized library for peer-to-peer communication. A lot of components are not actively used in most of the CL clients. So yeah, this will also eliminate a lot of these redundant components, and like also not compromise on any kind of performance issues. And finally, why not? This would help me and other fellows to develop a deeper understanding of the networking layer and understanding of libp2p. Yes, Max can take over now.
So maybe I can give you some more context about libp2p. So libp2p is a networking framework. It aimed to help developers to create P2P networks. So it provides a lot of building blocks to do so, like different transport layers, stream multiplexers, and so on. Contrary to Dev P2P, it was not designed to build Ethereum, but it's a more general use case, and it's owned, developed, and maintained by Protocol Labs, and it provides multiple implementation in different language, and each implementation is interoperable with the other one, and it's also used in every consensus client.
Okay, so now a brief walkthrough of the components of the P2P network, which are as a part of libp2p and which we would be implementing as part for the in-house implementation for Prism. So majorly there is a transport module, handshaking module, protocol negotiation, multiplexing, discovery, and messaging. And the right side image shows what are the features in libp2p and a filtration of what is used by Prism and what is not. Next slide, please. So yeah, first one is the transport module, which can be regarded just as a road or a bridge connecting two peers on which data is exchanged. So there are several internet communication protocols. There are WebSockets, WebRTC also used apart from TCP/IP or QUIC. But as part of the project, we would mainly be focusing on TCP and QUIC, since these are what is specified by the P2P specs. There is dialing, which is the process of opening an outgoing connection to a listening peer, and listening, which allows to accept incoming connections from other peers. So using whatever facilities provided by the transport implementation. And one of the components which we would be implementing is multi-addressing also, as a part of the transport module. And the next one is handshake. So before two peers can transmit data, the communication channel they establish needs to be secured. And this is what is provided by a secure channel handshake. And the protocol which does this is noise, and this is completely complete library or a codependency in itself. So this is not something which we would be implementing, but using as it is from the already implemented version. And why do we need handshake is basically because we need to ensure that the peer which we are talking with is really who he is claiming to be, and there is confidentiality of data, so that there is no eavesdropping or such things, and the integrity and reputation is avoided. Next slide, please. Yeah, the next one is protocol negotiation. So this is basically when a peer is dialing to initiate a new connection. The protocol ID, which basically specifies the details of the transport protocol in use, is sent along with the stream connection request, and other peers to which the connection is initiated just check the compatibility if they can accept the connection or not. So as part of this module, we would be working with multi-stream select or multi-select, which are the P2P, which are a part of P2P specs. And yeah, if the listening peer the dialing peer sends the protocol handles and all the details, and if the listening peer uh, does not support the requested protocol, it will end the stream. And if the protocol is supported, the echoing back of the protocol id would be done. So this is what needs to be implemented as part of the module. Next is stream multiplexing. So it allows to exchange different types of data within the same connection. So there are so how this helps is a single stream would block applications on one another, as one application would need to wait for another to finish utilizing the connection before being able to send and receive its own messages. So multiplexing allows creating of something like virtual connections, and this allows to send data maybe parallelly so that there is no blockings. And it's like having many lanes on a highway, so many vehicles can travel at the same time, just for an analogy. And as part of this, mplex and yamex are something which are specified by the p2p specs, and we would be implementing for the prism version. Next is peer discovery, which is, as the name suggests, identifying the peers with which the communication needs to be done. And the protocol which is specified by the P2P specs or is used by Prism is disk v5, but it is something which is not a part of libp2p, but uh, dev p2p, I suppose, and is out of the scope of this project. So this is also something which would be used as it is, I guess. Next is pubsub or the messaging. So it is it is a scheme for allowing the peers to receive messages of a specific type, just like if we have a chat application where we are just subscribing to, let's say, a game topic, and we are only receiving the messages of that type. So it is analogical to that. So there are several implementations which involve broadcasting or bootstrapping nodes, but as part of our project, we would be following the gossip sub scheme. So yeah, in this there are several methods in which there is subscribing to full messages or only metadata connection. This is internally for these are the parts of the internal implementations of gossip sub. And yeah, it helps with reducing the number of duplicates that the messages the peer is receiving. So yeah, these are majorly the components which we would be going through. Next, Rose can take over.
Um, Hi. So moving on to the roadmap for our project. So like for the first month, our first step is to thoroughly understand the specifications outlined in the README file of the P2P interface from the Ethereum consensus specs. So like this involves a detailed analysis of the components involved in the libp2p networking within the Ethereum beacon chain. Following the second month, we'll use existing libp2p implementations as references to guide our development. and we'll implement libp2b for the Prism. So like our focus will be on creating a package that includes only the necessary components, as the existing Go implementation of the libp2b library includes many components that Prism does not use. So like then moving on to the third month, we'll develop a comprehensive testing plan to ensure the reliability of an implementation. So this will include end-to-end tests, unit tests, and the performance benchmarks. So like we'll refer to the Prism documentation for the guidelines. And moving on to the fourth month, once our implementation is thoroughly tested, we'll replace the Go libp2b implementation in the Prism Beacon node with a new in-house version. And finally, the fifth month, we'll compare the networking performance of the Beacon node using the external Go libp2b implementation and our new in-house implementation on the Holisky testnet. So yeah, like we are open to the questions now.
Okay, guys, thank you very much. Yeah, it's been like 10 minutes, so let's do some question. Sure, did you have any questions? Yeah, I just want to say, folks, a great presentation. Thank you so much. Thank you so much, first of all. Yeah, I think it's great because also we know like protocol labs kind of spinning down their development power. So now having your own library, which is not maintained by them, is very useful. Excited about the project. Thank you so much. Yeah, I just want to say that like in these presentations, like you don't have to go to very details of specification of the existing protocol or like go too much into the weeds because we have a limited time. Just wanted to highlight that. But yeah, so if there are any questions, comments, Chirag, you had your hand up.
So I was just wondering if there was any initial analyses done for comparing what uh, in-house development would like bring to the table. Also, like I think I also have a follow-up doubt on that, which is like would it would it make more sense to take the existing implementation and kick out, or why we are not going for that kind of a strategy? Did that make sense?
Yeah, so like why to start from scratch and not to strip down?
Yeah, exactly.
Yeah. Guys, yeah.
I can answer for that. So yes, the idea is not especially to write from scratch, but the current libp2p from Protocol Lab, Go libp2p is very huge. There is a lot of function and modules we don't need and we don't use. So what we want, it is a slimmed down version of libp2p, really just which fits our Ethereum needs. So of course, if we can take given function from the Protocol Lab Go libp2p implementation and reuse it in our own implementation, it's perfectly okay. We don't have to re-implement everything from scratch.
Okay, that
Awesome.
makes sense.
Yeah, thank you so much, Manu, for answering, and thank you so much for being here, for mentoring. It's really great to see some mentors here. Thanks a lot, Manu.
Okay, you're welcome.
Awesome. Yeah, thank you so much, the whole team. Yeah, it's great to see a team effort and quite an important goal, 80K lines of code. Yeah, I think that's pretty unnecessary complexity for Ethereum. So better to take away some dependencies. I see Richa is next sign up, but I guess was the presentation with the previous team. So we should move on to the next one. Rory, if Richa, correct me if I'm wrong, but I think we can move on. Rory, guys.
Yeah, I think I'll go ahead and get rid of my screen ready.
Awesome, thank you. Yeah.
Cool. Everybody can see my screen?
Go ahead. Yeah.
Awesome. Okay, cool. Yeah, so for this project proposal will be granting support and documentation. So as some of you may or may not know, I'm fairly new when it comes to developing. So I thought this would be the best way for me to contribute to the protocol. But this project is basically focused on building out a more comprehensive support and documentation book for Grandine through a lot of research and trial and error. And then the motivation for this really is, Grandine is the newest consensus layer client but the documentation is on the lighter side, and I think it's important to have more comprehensive documentation around Grandine and its capabilities. And I think this is important because it'll help attract new users to the client, which would increase client diversity among CL clients. And this, to me, is also just really a perfect opportunity to kind of get in on the almost ground level because it's so new. There's a lot of bugs to be worked with and kinks to be figured out. So for me, helping to do this, I think would make a lot of users that are going to use Grandine in the future much more easier and have a much more easier time to just really work with the client. So yeah, so the future state really is currently I have several sections I think could be useful for Grandine. These are the following areas I like to be addressed, but I think it's likely to change as I begin to make my way deeper into Grandine. I'm taking a lot of inspiration from the Lighthouse and Prism documentation books. So whilst not everything that they have will be applicable to Grandine, I think this is a good base to work from. And really a lot of it does come down to, I think, what users would really like to see, where the interests are and what the motivations for people wanting to use Grandine in the first place. So I imagine that as I continue to go down deeper into this, that I will come across other bugs or issues that may also need to be documented that were never addressed in the first place. So whatever Salius and the team need help with the most, that is kind of where I will begin to dedicate my time. But ultimately, really, it's just a matter of presenting, giving this documentation book as much information as possible so that anybody could pick it up just as easily and begin running with it. As far as a roadmap, I kind of broken it down to like have the installation completed by the end of this month, have ETH Docker integration by end of August, and it go on so on and so forth. And then for any other sections that are identified, have them updated before DEFCON 7, basically. Yeah, so the other thing, so as I kind of mentioned earlier, client diversity is really important amongst ELCL clients. And so this is a statement from clientdiversity.org. Grandine, because it's fairly new, doesn't have as much market share as the others. I think it's by Grandine coming on board, it's helping to offer users more diversity. But there's, I think the missing aspect of this really, it just comes down to the documentation piece. So even when I first started looking at Grandine's information, it just wasn't that too much information to find. You really have to do a lot of your own research, trial and error, and debugging, which is a lot of fun, of course. But I think if they want to really make an impression within the community and end users within Ethereum, that there needs to be a much more stronger effort for documentation. So again, this kind of all comes back to my motivation on why I want to work on this. For the project. And then this was actually a Medium blog post that Salius had posted back in March, I believe. This was their first blog post when Grandine basically just was open sourced. So again, even for them, this client diversity is a big goal for them. And they have a lot of other goals that they want to achieve within the next couple of immediate goals within the next couple of months to a year. But this is the big thing. And so again, I think just from experience working in ETH Global and seeing hackers work on other partners in their documentation or lack thereof, the more documentation that there is, the better. And then selfishly, again, this is just my opportunity to really make sure that I am understanding what is going on at the protocol level, and then I really do want to get more exposure to something just kind of all as much as possible. And I think Grandine offers that opportunity for me and anybody else that wants to join to do that at the ground level. So this is my presentation. Any questions?
Awesome. Thank you very much, Rory. Any questions? Any comments? Yeah, thank you so much. It's really great. I mean, I really appreciate your work. Like the documentation is something that I was starting with in other projects, and documentation is half of the usability of the system. Like especially Grandine starting out soon. Recently means there's a lot of things to document, and it's missing in all of these like tutorials for people and so on. I think it's important for them to have a really user-friendly docs. Also, we started the EPF wiki without Grandin really in mind. I think it's mentioned there, but also there could be some more information on it. Missing, yeah.
Awesome. Cheers.
Yeah. Thanks for you guys. Any comments, questions? Last chance before we move on. Okay, we get added too happy next. Are we ready? Hey. Happy. No. If Red Too Happy is not here, there is Rose. Rose, did you already present with the team, or do you have presentation on your own? Yeah, just if there is a team presentation, there should be just one person signing up to present. It's always one per project or one per team. Yeah, Happy and Rose, if you guys are here, please let yourself known. Otherwise, there is Katya.
Yeah, I think Rose was in the libp2p
Yeah.
presentation as well. So, and I don't see Rhett in here, so I think we'll move on to Katya.
Yeah. So Katya, if you're ready.
Okay, yeah, I'm ready. Just sharing my screen. Can you hear me?
Yeah, all good. Yeah, awesome. Yeah, I thought it's 10 project, but now we are actually on time. I think that's great.
Yeah, can you see my slides?
Yep. PeerDAS metrics. Go for it.
So this is my project PeerDAS metrics. So my motivation, I got my motivation during the DevConnect Istanbul, where I was I presented on many talks and panels about scaling Ethereum, what current issues we have with it, and and there was a secret weapon there. So then I started to apply this knowledge, participating in scaling hackathons. In particular, I took part in the circuit breaker, working closely with Avail team, and Avail is the data availability project. So I just dived into it. That's why I chose this topic during my fellowship. I decided to focus on data. I won't go into the technical moments, everything about it. So just the main issues is that we can solve through PeerDAS is increasing the throughput, lowering the resource requirements. It's kind of main problems. So currently, PeerDAS has 3 stages. So currently we have blobs already implemented, then goes first dimension PeerDAS, and then the second dimension PeerDAS. The current state is we are on the one dimension PeerDAS, so we work with columns of data. When I joined the program, I could see that the clients, consensus clients, are going to test the implementation on using kurtosis mostly, and on the DevNet 1, currently DevNet 2. So I choose to focus on metrics because this implementation has a set of metrics, more than 20 for now, and probably it will be more. These are the examples of metrics like total count of reconstructed columns and etc. So my project is all about PeerDAS metrics. I will start from analysis, what metrics we have, what metrics we need. Then I'm going to visualize some of these metrics using Grafana. And probably if we decide that we need API for some metrics, so I hope we will discuss it with the clients. And probably I will take part in the implementation of API. And having API, I will have an opportunity to build some of the metrics on Dora. And though Mario gave an advice not to spread over the topics, but I would like to collaborate and to contribute into TECU metrics. So I'm going to build metrics for TECU. And I also going to collaborate with research team and consensus client teams, all about metrics, the results I have, the issues I have with it. So probably we will find something interesting because it's at the very beginning of testing. Yeah, I hope it will be useful. I also going to collaborate with fellows who work on Grandin. They implement PeerDAS part. So maybe testing or the part of metrics, the way we can collaborate. And yeah, I've already mentioned CL clients and research teams. And my mentors are mostly DevOps team. So I work closely with Barnabas, and the whole team supports me as well. Thank you. And I work also with Mitri from TECU team, all about metrics implementation on TECU. And probably if I have any questions about PeerDAS itself, I hope Tancred will support me. And I also can see Manu here. He's active about PeerDAS testing as well. So Manu, if you have any advice, you can DM me. I'm not sure we have time for it right now, but yeah, I would love to have some feedback or ideas for testing concerning metrics. Thank you.
Awesome. Thank you so much. Yeah, awesome. Thanks a lot, guys. Any comments, questions? Yeah, the monitoring the metrics are great. It's also a very important part. So looking forward to that. And yeah, if there are no more comments, questions, we have. Yeah, thank you. Awesome, good job. We have. Yeah, you let me know if you need to connect with Manu. And next is Caleb. Hey. Yeah. Are you ready? Can you share your screen?
Yeah.
Okay. Yeah. We get it. Awesome.
Am I good to go? Can you see my screen?
Yep, go ahead.
Yeah, all good.
Yeah, okay. Hi, everyone. I'm Caleb. So I'll be working on EIP7732 implementation in Nimbus. Basically, EIP7732 has to do with ensuring proposal builder separation. So my motivation for the project is that currently about 90% of block proposals outsource their construction of their blocks to external builders. By doing so, they are able to maximize maximize extractable value as those builders have specialized algorithms for ordering transactions and stuff like that. By doing so also, it enables validators to be able to run consumer grade software without bothering about building the blocks, the execution payload themselves. So this is just like an overview of the current landscape. So in the current landscape, the validator that has been chosen to propose a block, that's called the proposer, runs an external software, a third-party software. the most common one right now is MEV Boost by Flash Boost by Flashbots. So there is a need for a third party which acts as the trusted system. Then both the builders and the validators interact through the relay. So the whole purpose of MEV Boost is to like of EPBS, sorry, is to like abstract away this to abstract away the relay and create like a trustless system. So basically like why EPBS security wise it ensures that block construction follows the same security rules as the rest of the network. Decentralization it reduces reliance on centralized release as we have about only like few release controlling about the majority of the market. Then it helps MEV distribution to be like transparent and equitable, and it makes it accessible for almost everyone, and it creates a fair market. So what EPBS aims to do is like abstract away the whole purpose of the relay and create a trustless system, as I said. So it just involves like the consensus layer. It does involves implementing proposal builder separation at the protocol level. So there are currently different designs of EPBS that's been researched, but what I'll be working on specifically is the slot auction EPBS model. And in this model, from this diagram, basically in the purple phase, the the block proposal the block proposal proposes is beacon block. Then the second phase, we have the execution payload from the external builders, basically. So we have like different observers, the attesters, the builder observers that helps to ensure that this system works according to like the set down rules. So basically in each slot, we have a proposal block and a builder block, each of which receive attestations. And these blocks are bundled together for the final block that is proposed. So like aims, as I said, it also like so the aims of this model is basically like create a system where there are like unconditional payments to the builders, then creates like a trustless system where we have where all parties have to play by the rules set by the protocol. Then we are decoupling the execution validation from the consensus validation, basically, which helps to improve decentralization also in a way. So the main participants, we have the proposers, we have the validators, we have the builders, we have the PTC. The PTC is now like is the new innovation in the system basically. These are validators that helps to like attest that the builder actually like revealed the execution payload timely. Then specifications I'll be these are the specifications. All the specifications are actually they've been like designed already by the EIP document, so it has been specified already basically. So that I'll just be following this pattern. Then this will be my roadmap. Currently I'm understanding the Nimbus architecture. I have a mentor over the following weeks. I'll
All right. Seems like we've lost Caleb. So It looks like maybe he just rejoined. Caleb, are you back in action here?
Yeah, sorry.
Cool.
Sorry. Do you mind if I start again?
Oh, I thought it was just my problem. Yeah, go ahead. Share your screen, please. We cannot see you.
Oh, sorry. Can you see my screen? Hi, can you see my screen?
No, we just see the same screen that you had up before.
Oh.
Yeah, now it works.
Yeah.
Oh, sorry. About that. Hey, sorry. So hi everyone, I'm Caleb.
Well,
Can you hear me?
I don't think we need to start all the way over again. We got
Oh,
most of
okay.
it.
Oh, okay.
Yeah, just
So
continue. Just finish it with the roadmap and yeah. Just the end basically.
okay.
Yeah.
So the roadmap, basically I'll be following this roadmap. Then challenges that I'll basically have is that I am new to the I'm new to NIM, so basically I've been trying to understand the NIM language and all. Then trying to understand the NIM code base. My mentor has been helping me TESEC. Then creating trying to like look for trying to integrate it into the current name code base so that it functions properly. Then my goal will be to have a working and tested implementation of EPBS before DEFCON 7 basically. So that's all for me.
Would you go back to your roadmap and talk a little bit about your timeline? I am curious
Okay.
to hear a little bit more about how you plan to implement this. It seems like a big project to do so quickly, so I'm curious.
So I'm basically taking it I don't know, bi-weekly to 2 weeks. Since it already has like an implemented spec already, so basically it's just like looking for the appropriate it's going to probably be like a plug and play for most parts, I think. It's going to probably be like a plug and play for most parts. So it's just taking those specific design pieces and integrating it into the Nimbus code base basically. So I'm just basically like following these specified specs already that is already in the AIP basically. So like implement this, implement that, implement this, implement that, and write tests for them.
Cool. And who are you working with in terms of mentorship?
TESEC.
Yeah,
TESEC from
testing.
Nimbus.
Yeah. And no other fellows.
Okay. Kira is working on EPBS too, but he's working on it in prison, not on Nimbus.
Yeah. Right. Yeah, like for example, because in Prism, the EPBS was an effort which took like longer than EPF, and there were multiple people working on it. So also in NIM, I can imagine that the scope, even if it might seem like all specified, there is still a lot of things to figure out, and it might be a bigger scope than you imagine. But like if you definitely like if you are confident to do this, you should go ahead, and even if you do just half of the work, it's a great contribution to Nimbus.
Yeah, I agree. I think if I were you, especially after the first couple of weeks of actually doing some of the implementations and looking into Nimbus Client, maybe revisiting your roadmap and seeing if there aren't some, uh, you know, more like seeing if you feel like the timeline is going to change at all, and sort of keeping that a little bit more up to date as you progress through the program.
Yeah.
Yeah, but thanks a lot, Caleb. Yeah, wish you luck with that. It's a lot of work, a lot of courage. I think it's great that you're tackling this. Any more questions, comments on Caleb, guys? Anyone? Yeah, thanks for the presentation. Yeah, we have a last one signed up here, Hang Lang, but we also skipped Red Too Happy if they didn't try. Yeah, go ahead, Hang Lang. If you can share your screen and yeah.
Okay.
Yeah, awesome.
Do you guys see my screen?
Yeah, all good. Go ahead.
Okay. So hi everyone. So for my project proposal is to improve PDAS implementation in Gradient. And so why choose PDAS in the first place? Because PDAS is I believe that PDAS is a part toward the full dance charting because in order to scale the Ethereum, we cannot rely on the nodes storing all of the data. So it currently it around like 1.5 to 2 terabyte to store the data. And for the second is involve many interesting components like gossip SAP and KCG commitment cryptography. So before I joined the fellowship, I interested in cryptography and specifically on the zero knowledge proofs, and sure that after the fellowship, I will more workly on the cryptography part, and it also include in the Pectra apparatus, network apparatus. So it has some like a specific deadlines, and it is also in active development, which it have a bi-weekly breakout room on every Thursdays. And so why we choose Gradient to work on? So Gradient is a Rust implementation of consensus layer. So it is Rust using like a memory safe, and it offer like a C++ performance. And also I might say if a bit familiar with Rust, so it is quite challenging for you that is like a don't understand don't learn Rust before. So that's why it is a good option for us. And also it actually there are other clients implementation that written in like TypeScript or Go that also I familiar, but see like Gradient also have a small team, like only 3 to 4 contributors, so it need more support and more help on the implementation. That's why we choose Gradient. And on the roadmap, uh, so first, we have to backport the lib peer-to-peer from Lighthouse. So this part, Rahul from my fellow also did implement at that point, and currently we are doing update PDAS implementation based on the latest patch. So we currently working on that, and also we at the same time we try to test the interop with other clients. So actually the roadmap is not like a straightforward. We have to like spend a lot of time on the interop and the testing, because when we first start to test the word chain, we see like a lot of bug and a lot of it. So we have to move back and forth, back and forth. So the roadmap is subject to change in the future, and but the goal is to make sure that we compliant on the PDA spec, and also we ensure that the client with interop with other client implementation, and also ensure that the performance and security is mirror. And what the challenge is that, like Rory mentions previously on his proposal, if Gradient is because Gradient is just open source like a few months ago, so it doesn't have a lot of resource and documents, so it's quite hard for like a external contributor to contribute into the project. It has a limiting on the documentation, and also we new to the client testing and debugging, so it is quite hard for us like do like an interop thing. So we need to learn on that to identify what happened and what's wrong with like the logging and something like that. So, and also the benchmark and the metric to ensure like the performance and the securities of our implementation. So he is the our team, me, Hang Liang, and Rahul, my collaborator, and with support from Salus from Gradient team. And yes, that's all. Thank you.
Thank you so much. Awesome. Yeah, a lot of work on Grandine. They need help. They need contributors. I'm glad to see all of the support. Very well. Yeah. Guys, any question on this? Anything you'd like to comment or question on? Yeah, thanks a lot for the presentation. I think it's great. And yeah, we are doing pretty well on time, but I think we are out of presenters for today. Is there anyone here who have not present yet and would like to? There was right to have you signed up, who I didn't see here. Yeah, Derek.
I am able to present. I was just holding off. I'm not sure if my network is great. Or there's no one else.
I'm sorry, I can't really hear you.
Oh, maybe that's. I was saying I am able to present, but I'm not sure if my network or microphone is good where I am right now. If I should hold off, but if there's enough time, I can go ahead.
Have you signed up for today or?
Not today. I didn't know if I was going to be able to given network situations, but I seem to be lucky currently.
I would leave it for the next one then, since you don't have the. I hear noise in your mic, so I think it's not ideal now.
For sure then.
Just sign up for the next one, yeah. And yeah, everyone who's here and
good.
haven't presented yet, yeah, awesome. So yeah, everyone who haven't presented yet, please sign up for the next one. I will open the issue soon. So this week, please sign up for the next week's presentation on Tuesday, and I believe it will be maybe even the last round that we need, because now we finished in an hour, which is pretty good. Yeah, awesome. Thanks so much, everyone. I think that's it then. We saw many great presentations. I'm really excited. It looks. I'm always personally surprised about the quality of work for. That you were able to put together the research that you did in just like 4 or 5 weeks. Yeah, it's really great. Rory, yeah, of course, please send the PR as well. If that you presented a project doesn't mean that you don't have to have a project proposal or anything like that. The project proposal is what actually defines the project, the initial presentation and the final presentation, and the project proposal markdown document in the repo is what defines what you did in your in the EPF. So please write it down. Yeah, using the template you can write down the project. So yeah, open PR for that. If you have any questions, feel free to reach out. Feel free to open a draft PR and ping me for a review if you'd like some feedback. Yeah. And again, huge thanks for all the presenters today. The trailblazers who managed to start the presentations today. I really appreciate it. Really respect that.